Hello and welcome to the lecture on vector calculus. So in this lecture, let us see vector differentiation. So let's consider a vector. Let's say this is a vector. So vector has both magnitude and direction, and recap is unit direction. So when this vector is differentiated, let's say with time, then both magnitude and direction are differentiated. So here we have plus, here v bar is a vector field. Here this is rate of change of magnitude with respect to time. Here this is rate of change in direction. Consider a scalar function which is dependent on space coordinate. Sorry, this is only dependent on space coordinate. It is a scalar field. Phi is, but R is dependent on T. Let's say now if we perform d phi by dt, so d phi by dt will be is equal to d phi by dr, because phi is dependent on R, but R is dependent on T. So in this case we have to calculate d phi by dr and then dr by dt. When we multiply, we will get d phi by dt. Even though phi is not function of t, still we can calculate d phi by dt because r is dependent on t. Basically, r is a function of t. So here we can write r of t instead. R of t. Now the second case. Now see the second case. We have phi which is dependent on r as well as t, and we have r which is dependent on t. Now in this scenario we have to calculate d phi by dt. So here d phi by dt will be is equal to, we have to do partial differentiation because phi is function of r and t. So dou phi by dou r, and r is function of t. So here we have to switch to partial differentiation because uh, phi is function of r and t, and also here both phi and r are dependent on t. So phi is also dependent on t. So in order to calculate that, we have to do perform directly dou phi by dou t. So what does this suggest? Um, Here and here. So basically, this is we are finding d phi by dt because of variation of r in time and the variation of phi due to r. The variation of phi due to r because r changes with time as it is function of time. So this is one component. Plus d dou phi by dou t is because phi is also a function of time. This is the thing that we need to remember. And I already mentioned phi is a scalar field. So why it is scalar field? It is something that depends on space and time. That's why it is called field. It may be same or different at 2 points, but basically it is a function of space and time. That's why it is called field. Okay. So we have seen phi of r comma t. So I haven't told you r. Basically, r is a position that is radial distance. Now, if we so r is the radial distance. Now, if we have taken in the Cartesian coordinates, so phi is the function of x, y, z, comma t. Okay, and x, y, z are also function of time. D phi by dt is equal to, so here we have four terms basically. So anyway, understand the mathematics for whether it is one variable r or x, y, z, and if x and y, z are dependent on t, then d phi by dt will be calculated in this fashion. Now let's discuss gradient. So what is the gradient? Suppose we have a scalar field phi. Phi is a scalar field, and we know that the scalar field changes as it is a field. It changes uh, based on time and also the position in the space. Now, what does gradient operation gives is gradient, it gives the maximum. It gives maximum rate of increase of the scalar function at a point. Consider a scalar field phi, which is a function of xyz. So it is independent of time. So we have seen the differential length. For a change in differential length, what will be the change in phi? That is change in making total change in phi dr, which is equal to dx dy dz. So basically in x, y and z directions there is a small change of dx, dy and dz. So for that, what is the change in phi? So we have seen that it is a diagonal of the parallelepiped. So the diagonal of the parallelepiped, if you see in my lectures, you will understand that it will be increase of dx, dy and dz. So consider a point here x, y, z. Now consider another point which is x plus dx, x plus dy, sorry, y plus dy, comma z plus dz. So this is the other coordinate. So here you can see the increase is dx, dy and dz is the increase. So now when for that much change, what is the change in scalar field phi? That we can represent with d phi. Now we have to calculate how much it is. So how does that? How do we can do is calculate dou phi by dou x. So this is a partial differentiation of phi with respect to x. So how here we are doing partial differentiation. Now we are multiplying here with dx. So here dx is not the same as this dou x. Please understand the difference mentioned here. This is partial. So here dx is the change in x. Change in x is dx. So we are multiplying, we are differentiating, doing the partial differentiation of x and then multiplying with change in x. Here we have taken dx, so we are multiplying with dx. Suppose if there was 1 unit of change, so here we will calculate change in phi for 1 unit. Then it is not d phi. For example, it can be written as del phi, something like this. So if it is del phi, for change in 1 unit of x, y, z, whatever it can be, change in suppose x 1 unit and y and z 0, then at that time you will multiply for dou phi by dou phi 0. Okay, so that's different thing. But for calculating the change due to the changes here, this we are calculating as like this. Next to dou phi by dou y. Here this is dou y multiplied with dy because we also have the change small dy. Similarly, we also have dz, so we have to do partial differentiation. Please excuse for these practical issues, but please try to understand that sometimes writing on this pad is quite difficult, but I am being accurate here. Um, but be assured that I am very accurate about what I am doing and also adding value in understanding things. It's this is the thing that we calculated. So we have calculated this d5 change in phi due to an infinite system change dx by dt. Suppose if it is only due to dx and dy and dz are 0 and 0. So only for dx if it is asked to calculate, then here we have to multiply this with 0. So only dou phi by dou x into dx. Also, I will put questions. You can answer, you can solve and send your answers in the comments in the upcoming lectures. So we wait for that. Uh, you know. So now see how I am writing d5. Now just writing the above d5 equation. So consider this box as equation one. Rewriting equation one. So we can write like this: dou phi by dou x cap plus dou phi by dou y cap plus dou phi by dou z cap. I am doing the dot product with dx x cap plus dy y cap plus dz z cap. So see, both will be equal. Now here the dou phi by dou x into dx. So here dou phi by dou x into dx and x cap dot product is 1. So it will be dou phi by dou x times dx. Now multiplying dou phi by dou x cap dot into dy y cap. So x cap dot y cap is 0. Similarly x cap dot z cap is 0. So we will end up getting this will be coming like this here. Okay. Uh, Now rewriting the same will come as I'm taking the phi common. Just keep it like this. and here phi I am taking common. Okay, and we know the differential length uh, d or cap or dl cap, whatever the notation you can use, but just see that it is specified. So it is differential length, and we have seen in the previous lectures differential length in Cartesian coordinates. Either you can put here L also dl bar or dr bar. So, but just specify whatever you can use anything p any letter you want. So this is same as this one equation one. I'm just rewriting, not taking this. So in vector calculus, we represent this uh, thing with an operator which is symbolized like del. So here del means dou by dou x of x cap, dou by dou y cap, and dou by dou z cap. So it is easy for us to representation. For representation easiness, we are replacing that with times dr cap, dr bars. We have here d5. So this is the change. So see, understanding interpretation is very important in mathematics. Physically, what does this imply? This is change in phi, change in phi due to a change of dr bar. Okay, due to a change of dr bar. So it can be considered as an infinitesimal change in um, xyz. So basically dx, dy, dz, that, and this is the dr itself. Now when we do d phi by dr, that will be is equal to del phi. So what does this quantity gives? This quantity will give us, this quantity means maximum rate of increase of the scalar function phi at a point del phi. At a point, which is given by del phi. Okay. That point could be whatever the point that is considered, it will give us the result at that point. This is a gradient. So now gradient of phi, this will give the maximum rate of increase of scalar function at a point. We have to substitute the point coordinates in del phi. This is the Cartesian coordinates that we have seen for del. Now, how about del for cylindrical coordinates? Uh, See, in Cartesian coordinates, we have considered increase Let's use this Cartesian coordinates. We have used the differential length increase change in increase dx, d5 and dz. So in cylindrical it will be 0 and rho d5 and dz. And in spherical, see the lectures of these cylindrical coordinates and all. I have explained in detail how they are implied. And so for differential length increase, we have in radial direction dr, and so along the polar direction we have r d theta, and in azimuthal direction we have r sin theta d phi. So now when we are using when we are differentiating, we have to calculate the change for this only. So that will be, so del will be, in that case del will be what? For cylindrical it is dou by dou rho of rho cap plus, see here, this is the length, change in the length in the r cap direction. Similarly here it is rho d5 along the phi direction, and the other one will be along z direction. This is cylindrical. And for spherical, we have radial direction changes dr. So r d theta, theta r sin theta, rho phi, phi cap direction. This is spherical coordinate. I have already written differential length. So when you multiply in the same fashion here with phi, and that will give, and multiply it will differential length, you will get the gradient. So in order to calculate gradient, you have to do the mathematical operation del phi. So del phi is the gradient of phi, maximum rate of increase of scalar function at a point P. So here in Cartesian coordinate, point will be given as x, y, z. In cylindrical coordinates, the point will be given as rho phi z. And here will be given as r, theta, and phi. So basically, you have to perform this on the. So calculate del phi. First step is calculate del phi. Second step is substitute p del phi. So basically, del phi is a vector. Substitute p in del phi. Then at last, third one, magnitude of del phi will give the rate of, sorry, maximum rate of increase of phi at. So this is how we calculate the gradient. Thank you so much for watching this video, and regarding the solving the problems, etc., understanding this mathematics is very important. Once you understand the mathematics, the time required for solving the problems in EMT will be very less. Thank you so much for watching, and please subscribe this channel to get more videos.